Algae is normally harmless, but the right combination of warm water, high nutrient levels, and adequate sunlight can cause a harmful algae bloom. These blooms, which are now a serious problem, cause bodies of water to heat up, compounding the problem of global warming and a host of other climate change issues. This sets up a vicious feedback loop. Water made darker by the presence of the blooms absorbs more sunlight, warming even more and enhancing the conditions for more blooms. This contributes directly to global warming and overall climate change. In order to prevent this problem, our team has studied different ways to filter out algae from the water in an efficient manner. We studied different straining techniques, such as baleen, a mechanism whales use to filter microorganisms to eat. Although it was effective, we found that a common problem with straining was a buildup in concentrate. This is typical in most dead-end filtration mechanisms, as larger particles would get stuck and clog up smaller molecules from filtering through. So, we looked for filtration techniques that avoid buildup. After researching our problem, we found our answer in the very place where we needed to filter, the ocean. Manta rays are filter feeders, like many other ocean creatures. They pull plankton-laden seawater into their mouths, where rows of fibers help them swallow the plankton but release the seawater. This is an example of cross-flow filtration, as water exits through the side while concentrate moves forward. The New York Times released an article titled, "The Marvelous Filters in the Manta Ray's Mouth," pertaining to this phenomenon. In this article, 3 scientists created a model that would filter microplastics from the ocean using the manta ray filter structure. We decided to both repeat this experiment with microplastics to test its validity and repurpose it to filter algae. We designed our own filter using CAD and 3D printed a model that we could test. Then we built a system to test effectiveness of our filter. We first used small plastic pieces in the water to demonstrate the filtering system. As shown by the flow of plastics as water secretes to the sides, the tangential straining system was successful, showing proof of concept. The results are shown here clearly. Then we designed and printed a 3D model with finer slats in order to test with algae. This experiment was successful in sequestering algae. We believe that this design can help combat algae blooms and mitigate the effects of climate change.